Hi, this is Andrea Hendricks. Can you believe we are near the end of the semester? Only a few more topics to cover. Right now we're going to talk about systems of equations. Specifically, we're going to review linear systems and talk about nonlinear systems. Linear systems should be something that's familiar to you. It was covered in Math 98 extensively, and I realize not all of you took that course, but if you need to have more review than what I provide here, let me know and I can refer you to some materials that I've already created so that you can get the help that you need. So we're going to talk about reviewing those and methods to solve those, which deal with substitution, elimination, and graphing, and then extend those concepts to apply to nonlinear systems. So do you remember what I even mean by a system? A system of equations is just a set of equations that must be solved simultaneously. When we're dealing with linear systems, we're referring to a system of the form ax plus by is equal to c, and ex plus, well, let me go back, not e, I skipped a letter, d, dx plus ey is equal to f. So to solve that system, we're really trying to find the ordered pair xy that solves both equations. And what types of solutions can you have? I mean, graphically, that refers to this. If you have two lines that you're trying to find the common point between them, you can have something that looks like this where two lines intersect just one time, so there could be one unique solution. We could also have it where the lines are parallel to one another and they never intersect, so there would be no solution. And the third case is the two lines in the system could indeed be the same line, so every point on the line is a solution of the system. So there will either be one solution, no solution, or infinitely many solutions when we deal with linear systems. So when we deal with linear systems and solving by substitution, there's a very precise method that you have to follow. The first step in this method is to solve one equation for one of the variables. Doesn't matter which equation or which variable. Typically, you're looking for the one that has a coefficient of either 1 or negative 1. So in the first equation, 4x minus y is equal to 6. We can solve that for y because it has a coefficient of negative 1. If we subtract 4x from both sides, we would get negative y is equal to negative 4x plus 6. Divide everything through by a negative 1 to get y is equal to 4x minus 6. Now the second step is to substitute this expression into the other equation. Now in doing that, we would have the equation, 4x minus y equals 6 is what we use for the first one, so we have to use the other equation, 2x plus 5y is equal to negative 8. And in place of our y, we're going to put the 4x minus 6. And now the reason for doing this, you'll see, is that there's only one variable. And we know how to solve an equation with one variable. If we distribute, we would get 2x plus 20x minus 30 is equal to negative 8. So we get 22x is equal to, if we add 30 to negative 8, that's 22. So x is simply 1. Now, once we find the x value, we're not done. Remember, we need an x and a y to find the complete ordered pair that solves it. And so let me make some more room here by just erasing this. Our next step then is to substitute the known value into one of the equations to find the other variable. So it doesn't matter where we go. We could go back to the original two, or we could even go where we saw for y. Doesn't matter. So if we know x is equal to 1, to find out y, let's go back to the second equation. We'd have in place of x the value 1 plus 5y is equal to negative 8. So 2 plus 5y is equal to negative 8. If we subtract 2 from both sides, we get 5y is equal to negative 10. So dividing by 5 gives us y is negative 2. So the solution to this system is the ordered pair 1, negative 2. And how can we check? To check, we would have to plug in to both equations, because that's what it means to be a solution to the system. It satisfies both equations. So if we say 4 times 1 minus a negative 2 would really be 4 plus 2, which is 6, so that checks. 2 times 1 is 2, plus 5 times negative 2 is negative 10, so 2 minus 10 is negative 8. So it satisfies both equations, so we know we've done it correctly. Now let's treat the same system and just solve it with the different method of elimination and also graphing. To solve it by elimination, we're going to do something different. We're going to try to add the two equations together so that one of our variables is eliminated. Now the problem is that whenever you add them in the initial form, one of the variables may not be eliminated. And so prior to adding, you might have to change the equation somewhat, and the only way you can change it is by multiplying one or both equation by some number. And what number is that? Well, the whole idea is to find a number that's common to the coefficients of the variable that you want to eliminate. So, for instance, if I wanted to eliminate the x, I look for what number do both 2 and 4 go into, and that is 4. So my goal is to have coefficients of 4 and negative 4 on the x. Well, we already have a 4 represented in the first equation, so we need to have the second equation become a negative 4. So I would divide by the coefficient that's already there. Dividing by 2 gives me negative 2. So what I would have to do is multiply the second equation through by negative 2. So my first equation stays 4x minus y is equal to 6. My second equation, when I distribute by the negative 2, becomes negative 4x minus 10y is equal to a positive 10. Okay? And not a positive 10. Can I add today or what? Let me clear that out. Positive 16. Sorry about that. Very important. You have to make sure you distribute it to both sides of the equation, not just one side. Now, we multiplied by negative 2, and now we want to add the two equations. When we add, we get 0, right? The x's are eliminated because our coefficients are opposite. Negative 1y minus 10y is negative 11y is equal to 22. So dividing by negative 11 gives us y to be negative 1. Now, once we find one variable, we need to substitute to find the other. So this would give us what? If we substitute y equals negative 1, we would have 4x minus, in parentheses, negative 1, and that's equal to 6. So we get 4x plus 1 is equal to 6. And so 4x is equal to, subtracting 1, we get 5. So x would be 5 over 4. You guys, I'm thinking all along here I'm making a mistake. Did anybody see the mistake I just made? I'm so sorry. My brain is not working today. What is 22 divided by negative 11? Oh, I know if we were in class you guys would be shouting at me. I'm so sorry for that. We get negative 2. I was thinking this is not coming up to the right number. Let me go back and change this. It should be negative 2 Don't you love it when your teacher makes a mistake? Hopefully it shows you that I'm just human, okay? Okay, so we have 4y really plus 2. I'm not 4y. 4x plus 2 equals 6. So subtracting the 2 gives us 4x equals 4, so x is equal to 1. Because the whole idea is we should get the same solution regardless of the method that we chose. And I was thinking, well, maybe I copied the problem down incorrectly, but I found my mistake. Okay, so it's 1, negative 2. So, again, elimination is dealing with trying to add the equations in the system so that one variable is eliminated. If the coefficients are not opposites, you're not going to get the variables to eliminate. So the first step that you have to do is try to create opposites for coefficients of either x or y. And to do that, you're trying to find what's the common number that those coefficients go into. And then you want one of them to be that positive value, one to be that negative value. And that's where you have to multiply one or both of the equations by some number. Okay? Again, this was taught pretty extensively in Math 98, so if you have any questions about this, don't hesitate to contact me. Now, graphing would require us to graph both equations and then find the point of intersection. Now, with a method by hand, this is not an accurate method, right? If you were graphing by hand, because if those intersected at a fractional point or something like that, there would be no way to know that precisely when you're graphing it by hand. So the calculator definitely would be the tool to use if you had to solve it by graphing, and I'll show you that on the calculator video. But with linear systems, you can kind of at least get the idea. These problems here that I've selected may be pretty ugly to graph by hand, but we'll talk about it. If I wanted to graph 4x minus y is equal to 6, and again, graphing by hand would require you to have a graph and a graph paper and a ruler so that you're precise. 4x minus y is equal to 6. What I can do, one of two ways really to deal with it. We can start at the y-intercept of 6, right? Well, it's not in that form. Again, I'm losing my mind. We'd have to solve it for y. It's not in the slope-intercept form. If we solve it for y, we would get negative y equals negative 4x plus 6. So divide it by negative 1 to get 4x minus 6. So the y-intercept is negative 6, and the slope is 4. So if I graphed 0, negative 6, and then my slope is 4, which means go up 4 over 1. So up 1, 2, 3, 4 over 1. If I wanted to continue that, I could up 1, 2, 3, 4 over 1. And then I'm going to draw the line between those points. So this is my first equation, 4x minus y is equal to 6. If I wanted to graph 2x plus 5y equals negative 8, I would have to solve it for y. 5y is equal to negative 2x minus 8, and divide through by 5. So we get negative 2 fifths x minus 8 fifths. So what I would do here is graph negative 8 fifths, which is really negative what? Negative 1 and 3 fifths. Okay. And then I'd have to go down 2 over 5, down 1, 2 over 1, 2, 3, 4, 5. Okay. And there we have it. So you see that those two do intersect at the point 1, negative 2, so that confirms our solution that we found. Okay. Now, let's talk about nonlinear systems. Nonlinear systems are going to possibly have a line in there, but you're going to deal with nonlinear things like parabolas or circles. Absolute value equations, anything like that could be found in here. So you might have, just to kind of get a picture of something, a circle for one of your equations and a line. So you might have two solutions to this. Or you might have a circle and a parabola where there might be 4 solutions. Okay? or you might have a parabola and a line where there's no solution. Okay, so the types of solutions really are going to change depending on what types of equations we have in our systems. So we're going to talk about how you can use substitution and elimination, and really the criteria is exactly the same. To use substitution, you've got to solve one equation for one variable, substitute it into the other. To use elimination, the equations have to be in the same form, and the goal is to add them to be able to get one of those variables to be eliminated. So if I have y is equal to x minus 1 squared and x minus 3y is equal to negative 1, to use substitution, I'm going to solve one of these equations for one of the variables. Well, you could think y is already isolated, so you could do that, but actually it's easier if you can plug into the squared expression instead of vice versa. So my first step is going to be to solve x minus 3y equals negative 1 for x. So we would get x is equal to 3y minus 1. Now, step 2 is going to be to substitute this expression into the other equation. So in my other equation is y is equal to x minus 1 squared. What am I going to do here? In place of x, I'm going to put 3y minus 1. And then the rest of my equation stays the same. So I would really have y is equal to 3y minus 2 squared. So to solve this, I've got to square this binomial. I would get 9y squared minus 12y plus 4. This is a quadratic equation, so we need to solve it by subtracting the y to get 9y squared minus 13y plus 4. Now this equation factors because 9 times 4 is 36. And the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The factors of 36 whose sum is 13 are the 4 and the 9. But, right, 4 plus 9 does give me 13. So if I can arrange my factors so that I get a 4 and a 9 as my outer product, both signs are the same because the last sign is positive. So I would get 9y minus 4 times y minus 1. Now if you don't use factoring, you can use the quadratic formula and still solve it. So this tells me that 9y minus 4 is 0, which is y is 4 nines, right? If you add 4 and divide by 9. Or y minus 1 is 0, so y is equal to 1. Now we're not done. Notice a difference here. I've got two solutions for y, so I've got to find two solutions for x, or however many solutions for x. I have to find a corresponding value of x for each y value. So to find x now is my third step. So I've got two conditions. I've got when y is 4 ninths and when y is 1. So to find x, we know x is 3y minus 1. So x is 3 times 4 ninths minus 1. But 3 times 4 ninths is really 4 thirds minus 1. 4 thirds minus 3 thirds is just 1 third. And we also know x is equal to 3 times 1 minus y. Minus 1. Which would be 3 minus 1, which is 2. So we have two ordered pairs that are solutions. We have 2, 1, and also 1 third, 4 ninths. Okay? Because this is a parabola, right? A vertical parabola, and this is a line. So this is saying the line and the parabola intersect at 2 points, and there they are. Now, to use elimination, we have x squared plus y squared equals 10, and 2x squared minus y squared equals 17. The goal is, again, we want to add so that one variable is eliminated. Well, notice already that the y coefficients are opposites, so we can add those two equations together. So we would get, remember there's an understood 1 there, a 3x squared is equal to 27. Dividing by 3 gives us x squared is equal to 9. Applying the square root property tells us x is equal to plus or minus the square root of 9 or plus or minus 3. So we have two cases. Now we need to find the y values. So we know that x is either 3 or negative 3. What we do now, we plug back into one of the original equations. So we'll plug into the first equation, and x squared plus y squared is equal to 10. We know x is 3 squared plus y squared equals 10. So 9 plus y squared is equal to 10. We can subtract 9 to get y squared equals 1. And again, we have to apply the square root property. So y would be plus or minus the square root of 1, which is just plus or minus 1. So when x is 3, there's two y values at work. So what that means is there's really two solutions from this, either 3, 1 or 3, negative 1. Now we plug in x to be negative 3, really the same process, and find y. So x is negative 3. It's not really going to change anything, is it? Because negative 3 squared is 9 plus y squared equals 10. So this is the exact same equation that we just had, so we know our two solutions are going to be plus or minus 1. So this tells us we also get two more solutions here. We have negative 3 paired with the 1, and also negative 3 paired with the negative 1. So this equation, or system rather, has 4 solutions. Okay, all of those solutions. Now, this is a circle and a hyperbola. I mean, I'm not going to graph it precisely here, but just to give you the picture of what's happening, it looks something like this. So there are 4 solutions that we would have. Okay. Now, let me conclude with 2 last examples here, working with elimination as well. If I have 2x squared plus 2y squared equals 20, and 3x squared plus 3y squared equals 30. Well, to eliminate either x or y, let's choose to eliminate x. The common number that both 3 and 2 divide into is 6. So I need to have 1 to be a positive 6 and 1 coefficient to be a negative 6. So if we make our first equation have a coefficient of positive 6, 6 divided by 2 is 3. So we would need to multiply by 3 to get 6x squared plus 6y squared is equal to 60. To make the second equation have a coefficient of negative 6 divided by 3 is negative 2. So we can multiply that equation by negative 2. So that gives us negative 6x squared minus 6y squared is equal to negative 60. Remember to distribute it through the entire equation. So when we add, something interesting happens. Notice our x's are eliminated, as are our y's. So we really get 0 is equal to 0. Anytime you get 0 equals 0, that implies that the two equations in the system are the same. And you might have noticed that. Do you notice the first equation, if you divide by 2, you get x squared plus y squared equals 10. The second equation, if you divide by that common factor of 3, you get x squared plus y squared equals 10. So they're really the same equation disguised in two different formats. So the way that you would write the solution is we have to indicate that every ordered pair on this graph of this circle is a solution. And the way we would do that, if we let x represent our independent variable, then we could solve for y and get this. So we can choose any arbitrary x, and the y value is going to be what? Well, we have to solve for y. So if we have, from the first equation, we know x squared plus y squared is equal to 10. So if we solve for y, we would get y squared is equal to 10 minus x squared. So y is going to be plus or minus the square root of 10 minus x squared. Okay. So we would have either x paired with the square root of 10 minus x squared, or x paired with the negative square root of 10 minus x squared. Okay, but really what that's saying is that every point on the circle is a solution. Now, looking at this problem, x squared plus y squared equals 4, and 5x squared plus 5y squared equals 28. Well, we want to eliminate one of the variables, so let's choose to eliminate y in this case. So what's a common number between 5 and 1? Yeah, 5, right? 5 is the number that both 1 and 5 divide into. So we need to have a positive 5 and a negative 5. The second equation already has our positive 5, so we need to get the first equation to have a negative 5 as its coefficient of y. Negative 5 divided by 1 is negative 5. So if we distribute through by negative 5, we would get the coefficient we need. That's negative 5y squared minus, negative 5x squared minus 5y squared is equal to negative 20. Our second equation remains unchanged. Now when we add the two equations together, again, notice what happens. The x's and the y's are eliminated, so we get 0 is equal to 8. But this time that is a contradiction, a false statement. So there is no solution. That means that the two graphs would never intersect. In fact, x squared plus y squared equals 4 is a circle of radius 2. 5x squared plus 5y squared equals 28 is actually a circle with radius the square root of 28 over 5, whatever that happens. But really, what we're dealing with there is concentric circles, a circle within itself, so those two are never going to intersect. Okay, so there's no solution. So just using substitution and elimination to solve analytically for nonlinear systems is really the new thing, but it's really the same skills that you learned with solving linear systems. So if you have any questions, don't hesitate to contact me. Thanks.